So I have two limits that I like to find here, and you notice that the function is the same for both of these. All this changed is what x is approaching. So the function is a rational function, and it's simplified as much as it can be. Right? There's nothing else that I could cancel between the numerator and the denominator. And at both of the two limit points that I've chosen, -1 and -2, the denominator is going to 0. So when you have a situation like this, where it's a rational function, it can't be simplified any further, and the denominator is going to 0 at the point that you're interested in, one of two things is going to happen. Either you're going to have a situation like this, where the function splits at the asymptote. It goes up to positive infinity on one side and down to negative infinity on the other side. Or you have a case like this, where it's going to the same place on each side. Okay, so in each of these cases, right, in the first case where it splits, we would say that the limit doesn't exist. And in the second case, where it doesn't split, where both sides are going in the same direction, in this case, we would say the limit is plus infinity in my example here, or if it's going down on both sides, then we'd say it's negative infinity. So how do we determine which is which? Okay, well, let's look at our function over here. I'm going to look at the first one first, right? The situation where x is going to -1. Well, what you want to do is you want to look at values on either side of -1, but that are really close to it. And I say really close to it, that's important. You notice that the other place where the denominator is 0 is going to be -2, and that's really close to -1. Right? So when we're picking a value that's close to -1 to check, it needs to be closer to -1 than any other places where the denominator is 0. So in other words, for -1, don't choose 3 or -3. Right? That's way over on the other side of -2. So I'm going to look at -1.5 and -0.5. And I'm going to ask myself, what is the sign of the function at each of those points? I don't care what the actual numeric value is. All I care about is its sign. So at -1.5, the numerator is negative. That squared part is always going to be positive, no matter what number I put in there. And -1.5 plus 2, that's positive. A negative number divided by a positive number is a negative number. Okay, good. Hold on to that. Try the other side. If I put -0.5 in here, I get a negative number in the numerator. Again, that squared part is always positive. And when I put -0.5 into the x plus 2 part, I get 1.5, which is positive. Right, so I got a negative number on both the right and left sides. That tells me that I have actually the opposite case of what I had here. I have the case where the function is dropping off to negative infinity on both sides. So that's going to be my answer. This first limit is negative infinity. Good. Now let's try with the other one. Right, and I'm going to do the same thing. I'm going to pick numbers on each side of -2. It's okay to use -3 here, and because -3 isn't between -1 and -2. And I'll use -1.5 again. And I'm going to do the same thing, checking out the signs. Since I've already done, excuse me, not -1.5. Since I've already done this with -1.5, I'm not going to do it all over again. I already know the function is negative there. So if we put -3 in, what happens? Then the numerator is negative. The squared part is always positive. -3 plus 2 is negative. And this time, I got a positive number. So the function is going in opposite directions. That really does look like this example here. It's going up to positive infinity on the left-hand side, down to negative infinity on the right-hand side. So for this one, I would say that the limit does not exist.